Okay, so let's take a look at 4 or 5. You guys already have a little kind of preview, okay, of what we're going to do. As Mr. Rice said, the goal here is to take equations that have fractions and get rid of them. So we don't like to work with fractions. It's kind of complicated. We get denominators, all that stuff. All right, so here's a typical equation, okay, that could have fractions in it. Okay, I just want you to look at it. Maybe we'll come back to solving this one later. But the idea here is if we were going to try to solve this using what we know right now, we'd have to subtract the 3/10 to the other side, and then we'd have to multiply by the reciprocal, 5/4. Well, that's a lot of fractions to work with. So what we're going to do is try to find a number we could multiply everything by that's going to make all my denominators 1s. Okay, that's the goal. All right, so what we'll do is we're going to use that chart, okay, that note sheet you got. And in this particular problem, you'd be looking at 3 rows. You'd look at row 5, row 10, and row 2. And you try to find the smallest number in all of those rows. Does anybody see what the smallest number is in row 5, row 10, and row 2? Logan? 10. Yeah, 10 would be the perfect number here. If you were going to multiply everything and you had to pick a number, I'd say 10 is the perfect one to pick. And we'll go through it in a little bit, and I'll show you why that would work.
Guys, I'm taking any notes here, but just listen right now.
All right, so the idea, I already said this to you guys, we can get rid of the fractions by multiplying everything by what's called the least common multiple. Okay, I'll probably just abbreviate that LCM. All right, so that's just for me to kind of give you the big idea.
So guys, on your notes we can eliminate the fractions by first, and you're going to fill in the rest. You're going to write in multiplying each term by the smallest number that is divisible by each denominator.
And that smallest number, that's called the LCM. Don't get too worried about memorizing what it's called. We just want you to know how to do it. Okay? We're also going to keep the denominators pretty small, all right? Because if the denominators start to get too big, then you're trying to look at multiples that could be huge, in the hundreds. So we're going to try to keep the denominators pretty small. Okay, and keep that sheet out as you go through the problems. That chart we did on the warm-up, that's going to help you guys out. We'll look back at that throughout this lesson.
Guys, above what you just filled in, right? So above what you just filled in, so we have all your multiples and stuff like that, and you have a black line. What's the first word after that black line? Huh? Denominator, right? What would be our definition for denominator? Bottom number in a fraction. So denominator, you want to write bottom number in a fraction. I know most of you guys know, but it's still good to have it on there. Bottom number in a fraction. So denominator is going to be bottom number in a fraction. Bottom number in a fraction.
All right, so let's take a look at this. Okay, we're actually going to do the very first problem I just showed you. Okay, 4/5 x plus 3/10 equals 1/2. So to find what we got to multiply everything by, you need to find the smallest number that each denominator would divide into. We got to find a number that 5 goes into without remainder. We got to find a number that 10 goes into without a remainder, and a number that 2 goes into without a remainder. The smallest one we can think of. And you guys already told me what it was. What's what's the least common multiple of 5, 10, and 2? 10. All right, so 10 is the number that we're going to use. You can also find it on your chart. Any question why we're going to use 10? Yes? Yeah, 5 goes into 10, 2 goes into 10, and 10 goes into 10.
As you're looking through your chart, for each of those multiples, 2, 5, 10, 10 will be the number that comes up first of all of them. It'll be the first one that they all have in common. There may be others, but that's going to be the first one. You want to use the first one that they all have in common.
Okay, what I'm doing, I'm just copying it down so I can start to work on it.
So guys, you have space on your note sheet, for example, 1. If you already wrote it in, that's fine. If you're writing in right now, you may want to write it in how Mr. Hager did. Just give yourself a little bit of space for your multiplication.
All right, now we've got all fractions here. So people said to multiply by 10, but how can I make 10 a fraction? I want to have a number in the bottom. Yeah. Yeah, we'll make it 10 over 1. So what I'm going to do, and I'm doing it in a different color so you can see it, we're going to multiply everything in red by 10 over 1. So I got to do it on the first term, the second term, and bless you, and the third term. Okay, now what I'm going to do, I'm going to reduce it before we multiply, just because it'll keep the numbers smaller. We're either going to have to reduce it now or reduce it later. Okay, we got to reduce it at some point. So why not try to work with small numbers if we can? All right. Let's start with the first one. Sam, how many times does 5 go into 10? 2. How many times does 5 go into 5? Once. We're going to see this pattern of 1 coming up a lot in the bottom, if we've done it correct. Jalen, how many times does 10 go into 10? Once. And how many times does 10 go into 10? Yeah, just once. And then the last one, Gavin, how many times does 2 go into 10? 5. And how many times does 2 go into 2? Once. All my denominators just became what? They're all ones, which means...
When you find your lowest common denominator, all your original denominators from the original problem are going to become 1.
Okay, which basically means now we're not going to have any fractions. So let's multiply, remember, straight across, and let's see what we've got. Ariana, what's 2 times 4?
8.
Yep, and then what letter are we going to put with it? Nice job, 8x. Okay. Notice in the bottom.
You can put it over 1, but you don't have to. 8 over 1 and 8 mean the same exact thing. Anything over 1 is itself.
Okay. On the next one, 1 times 3. Maria, what's 1 times 3? 3. What's in the denominator? Yeah, just a 1. 1 times 1. Okay, we don't need it. And the last part. Ben, what's 5 times 1? 5. What's in the denominator?
1.
1 times 1, just 1. Look how much easier our equation is now. Okay? How many people think this one looks a lot easier than the original? Yeah, it doesn't have the fractions, right? Now we'll just solve it using the steps we learned all week. Justin, what would be my first step to solve that?
Is that that?
Yep.
So subtract 8.
Careful, when you have a number next to a letter, that's going to be a divide. But that's the very last thing we do.
Justin, you're on the right. You're close. You're on the right side. You just picked the wrong thing. You're on the right side of the equal sign.
Subtract 8.
Good man.
Yeah,
Yeah, you got it.
Where else?
from 5.
Good. Can you tell me, Justin, what I've got left here? 5 minus 3? 2. Good. And now we're almost done. Corey, what's my last step? Good. Divide by 8. Divide by 8. And can you tell me what I get, Corey? You can leave it as a fraction. Yeah. Notice how he reduced that? 2/8 reduces to 1/4. Divide the top and bottom by 2. Don't worry about changing that to a decimal.
Wow.
Okay, so that's basically the kinds of problems we're going to look at. Okay, we'll try a couple more of those maybe one other type, and then a word problem. Okay, questions on that one? All right. Let's try this one. Okay, when I look at this right away, I'm focusing on the 2, the 4, and the 8. And I'm thinking, I'm going to look at that chart, and I'm trying to find the smallest number that 2, 4, and 8 all have in common on that list. Yeah, I'm just going to give people a second to look at it. But, yeah. Okay, as you look at that list, okay, Corey, I think he already has it. What did you say it was, Corey? Yeah, it's 8. So what am I going to multiply everything by, Corey? Because we like to do it as a fraction. 8 over 1. So that's your very first step. Multiply that by 8 over 1. Just try to squeeze that in right there. 8 over 1 times 8 over 1. Okay. And now, if we pick the right number, what are we hoping happens to all the denominators? They're all going to come out to what? 1. So hopefully we don't have any fractions when we're done this. Okay, Logan, how many times does 2 go into 8? 4 times. And how many times does 2 go into 2? Logan? Yeah. All right, next part. We have 8 and 4 we can reduce. Ryan, how many times does 4 go into 8? 2, nice job. How many times does 4 go into 4? Just once. So far, so good. All right, Callan, last step. How many times does 8 go into 8? Once. And then 8 divided by 8? 1. Look at my denominators. All ones. That's good. Okay, Ryan, what am I going to get when I simplify this first part?
4
4.
over 1.
You know what? We could put it over 1, but we don't need to anymore because we got rid of the fraction.
4x.
Yeah, that's what I was looking for. Nice. 4x plus. Okay, what's left in the second part? Go ahead, Cor. 2. 2 times 1. We get 2. And in the last part? 5. Look how much easier that equation is going to be to solve. No fractions, maybe at the very end, but no fractions right now. Victor, what's my first step here?
Subtract 2.
Good. Subtract 2. Okay, and 5 minus 2 gives me 3. And last step. Then I'm done.
You divide, right?
Yep.
So it's just going to be x equals 1.
I don't know what to divide by yet.
Let's divide by
By 4? Okay, and what do you get for x?
x equals 3 over
X equals 3 over 4. Perfect. That's it. Right? So if you get the basic idea of solving equations, the only extra step you got to do to start is multiply everything by that LCM. Okay, anybody have any questions so far? Okay, let's try one more kind of easy one, then we'll try one more that's a little harder, and then we'll do a word problem. Okay, this one's actually a little easier. What's the only denominator here I have to focus on? 3. So, what's the smallest multiple of 3? Nope, there's one even smaller than 6. 3. Right? So, what could I multiply everything by here? 3. All right? If it's kind of confusing, like, well, wait a minute, I'm used to seeing all the denominators. These other denominators are already 1s. That's all, already 1s. So just multiply, just look at the one denominator you have, find the smallest number that's a multiple of 3, and it's 3. And then we have to multiply here and here. Okay, maybe I should have done that in a separate color so you can see what I multiplied by. Let's just do it like that. So I multiplied everything by 3. Got to do it everywhere. Let's see. Kevin, what's 3 divided by 3? 1. And then 3 divided by 3 again? 1. And now the others we don't have to reduce. The denominators were already 1s. So we just do the arithmetic. There's nothing to reduce. Okay, Justin, what do you get when you simplify this first term? Okay, what are your numerators? What are the numbers in the top here? 1 and 2, so multiply them together. 2, and then what letter do you have with it? X, 2x. All right, good. Gage, can you do this next one for me? What do you get here? Yeah, Gage. Careful, you're going straight across, right? You just multiply straight across. One more time?
21 over 1?
Yeah, just 21 over 1. Or you could just put 21. Yep, good. And the last part. Who can tell me what's going to be on the right-hand side? 27. All right, so the one disadvantage to this is sometimes your numbers get a little bigger, but you don't have any fractions. So, all right, let's see, 2 steps left to solve it. Sabrina, can you give me one?
Minus 21 on both sides.
Good. I'm going to minus 21. So 27 minus 21 gives me 6. Now the numbers aren't too big. Zach, what's my last step? Divide 2 by itself. Anything else?
Divide 6.
Divide 6 by 2. All right, so what's my final answer? 3. So x 6 divided by 2, x equals 3. Good. Any questions on that? You guys feeling, how do we feel about these kind of problems? We doing okay? Okay, on the test, you're going to have more of these type where all of them are fractions. Probably not as many where you just have one fraction, because I want to see if you guys know how to do that. All right. Let's give this one a shot. This one's a little different. It's the same idea. Right? Look at those denominators. What are my denominators here? Somebody just read off the 3 denominators to me. Yep. 4, 8, and 5. So we're looking for a number that is in all 3 of those lists. You want to see one? 40. Anybody find one that's smaller? I don't think so. All right. So 40 is the smallest number we got. So when you multiply things by 40, things get a little big. So we're probably going to use our calculator. Now, we're going to multiply each of these fractions by 40. But look at the tops here. Look at the numerators. Each numerator has 2 things in it. Well, except the last one. Okay, but these both have 2 things. Anytime you see a numerator with 2 things, I want you to do this right away. You see 2 things in the top, put it in parentheses. And let me show you why. So what did we say we're going to multiply everything by? 40. What property is going to end up happening right here? Distributive, right? If you multiply a fraction by a number, you have to do it to everything that's in the top. That's why I had you put parentheses, so you'd remember to distribute. Okay? We're going to have to distribute, but distributing 40 is kind of a big number. I think I'm going to reduce it first. Okay, but let's just finish writing in what we have. So 40 over 1 and times 40 over 1. Just squeeze it in. It's kind of hard sometimes. All right, so now reducing is going to make everything a little smaller. Anybody help me reduce that? 4 goes into 40. How many times, Callan? 10? It's not as bad now. It's a little smaller. And 4 goes into 4 how many times? Once. Okay, so we got that. Next one. What can I cross 40 out and make it here? 5. 8 goes into 40 5 times. 8 goes into 8 once. All right, that's not bad. Okay, we only have to distribute a 5. See how much smaller it made it by reducing first? It's kind of helpful. And the last one. What can I reduce and make 40 in this case? Maria? 8. 5 goes into 40 8 times. 5 goes into 5 once. All right, so we've done all that reducing. Let's just copy over what we have and clean it up a little bit. We've got 10. We have x plus 8. Plus, we've got 5. Negative x plus 5. Okay, keep that in parentheses. Equals, what's on the other side? 8x. Now this is just like one we did, I think we did this on Monday. We've got a distributive property, and then we'll combine like terms. Let's start with 10 times x. Victor, what's 10 times x?
10x.
Good, 10x. Sam, what's 10 times 8? 80, good job. Okay, next part, we've got positive 5 times negative x. Okay, be careful there. Anyone think they can do that one? What's positive 5 times negative x? Zach? Negative 5x. Good job. Positive 5 times negative x, negative 5x. He did great on that, right? Positive times negative is a negative. Ryan, what's positive 5 times positive 5?
It's 25.
Good. And the last thing is 8x. All right. Anybody see some like terms on the left-hand side I can combine? You don't have to combine them, but just name them. I'll underline them. Yeah.
10x and 5x.
Good, I like it. 10x and the negative 5x. Does anybody see 2 other like terms we can combine? Yep. Ariana?
80 and 25.
Good. 80 and 25. Okay, I'll help you guys out. I'll combine what's in red for you. 10x, take away 5x. That's 5x. Can somebody else help me with the ones in green? Positive 80 plus 25. 105. Okay, now our equation's not looking too bad. Right? Look what it started out as. It started out as this crazy mess. Now we're down to something that's not too bad. I've got 2 steps left. Anybody tell me just one step? Yep.
Subtract 5x.
Perfect. Okay, you're going to subtract 5x. Subtract 5x. That's gone. Still have that 105 on the left. And 8x minus 5x leaves me with how many x's? 3x. Okay, now we're down to our final step. How do I get x by itself? Go, yeah, Alexis? What's that? This one? Well, we have positive 10. Take away 5. Yeah, so the positive is bigger. But yeah, you've got to be careful. Always double check if your positives and negatives are right. And Corey, what were you going to say about that last step? There you go. Divided by 3. Let's use our calculator. X is 35. So kind of a lot of work, a lot of writing, but it's the same steps you've been learning all week. You just reuse them. Okay? That would be like the hardest kind of problem you can possibly have. Nothing gets any harder than that today. In fact, the rest are going to get easier. I just wanted to throw one of those hard ones in. All right, so we got this one, and then we got the word problem. You know what we might do? Let's go to the word problem. Okay, if we have time, I'll come back and have you guys try this one on your own. All right? So let's do the word problem. Then maybe we'll come back and try this one. Okay, the last problem has to do with what's called an average, okay, or a mean. Does anybody know what that is? What's the average mean? Like if you've got two numbers and you want to average them, how would I do that? Yeah, you add them up and then what? Yeah, you add up all the things you want to average and divide by how many you have. Right? So I do that when I'm doing your grades, right? I look at all your tests, I add them up, divide by how many, here's your average. Right? So that's how you find an average. You add up all the numbers and divide by how many you have. That's exactly what someone said. Okay, how many people have done that before, found averages? Yeah, it's pretty straightforward. So I'm going to give you guys a problem that you might ask me this kind of question as the school year goes on. Okay, right now we've got a student and she's taken 3 tests. Okay, these are the grades she's got so far. She has a 70, an 80, and a 90. She's got one more test left. All right, and she wants to make sure she gets at least a 70 for the term. All right, so right now she's taken 3 tests. Those are her grades. She's got one more test to take, and she wants to make sure she has an average of a 70. All right, so that might be the kind of thing you want to know. You know, like, Mr. Hager, these are my test grades. What do I have to get on the last test to make sure I get a 80 or a 70 or whatever it happens to be? All right, so let's see if we can figure this out. All right, what did we say when you want to do an average? What do you do with all the numbers you want to average? You add them all up, and then what? Divide by the amount you have. All right, so let's look at what she's got so far. She's got 3 tests she's taken. How many more tests does she have to take? How many more, Ryan? She's got one more test. Okay, the next test, one more. So by the end of this term, after she takes this next test, how many tests will she have taken? 4. All right, so that's going to be the total amount of tests she takes. Now, we know 3 of them. Okay, let's write them down. Got 1. There's 2. There's 3. Now, do we know the score she's going to get on the next test? Nope. That's what we're trying to find. So for now, in algebra, how do we represent something we don't know? Yeah? A variable. All right, so she's going to have one more test. So let's just put plus, and let's pick a variable for that last test. Yeah, we could pick x. Okay, we don't know what it is yet, but we're going to add it to all the other tests. And how many tests will she have taken? 4. And we already know what we want the average to come out to. The average is going to be on this side, after we add up all 4 and divide by 4. What does she want to get for an average? She wants to get a 70. Okay, that's the hard part, setting up your equation. Now we just have to solve it. All right. In that numerator, what could I do with all these numbers? Yeah. Yeah, let's just add them up. 70 plus 80 plus 90. Okay, that's 240. So right away, that's already going to make it look a little simpler. Now we're going to use a trick we learned today. What's my denominator on that left-hand side? 4. Do I have any other denominators anywhere else in the problem? No. So I want you to look at your list. What's the smallest multiple you can have of 4? Corey? 4. So we're going to multiply everything by. We're going to use 4, but how am I going to write it? Good. 4 over 1. Okay, times 4 over 1. Now, I said anytime you have two things in the top of a fraction, what do you want to make sure you do? You have this 240 plus x. Yep. Just in case there's a number we have to distribute, we remember, oh yeah, we got to multiply both of them. All right, let's reduce and see what happens. Ben, how many times does 4 go into 4? Yep, and then 4 into 4?
Once.
Just once. Okay. So look at what we're going to be distributing. What number do we have to distribute? 1. Does multiplying by 1 change anything? No. So this time we don't even have a number we have to distribute. It basically just canceled out. So all we have is 240 plus x. If you want to distribute the 1, you could think about it in your head. 1 times 240 is 240. 1 times x is x. Okay, didn't change anything. Okay. And what's on the other side? I have 4 times 70. 280.
First grade, they told me never to say 200 or 100.
Oh, yeah?
Yeah, they always told us to say 180.
180? 280? Yeah, that's fine. That's okay. Won't be picky about that. One step left. Okay, my last step. And then I'll know what she needs to score on the test. You can tell me my last step. Maria? Subtract 240. So what's the score she needs to get on the test?
70. Oh, well, she wants to.
Yeah, she wants an average of a 70, but what's her score going to be on the last test? Yeah, she's got to get at least a 40. Okay, if she gets higher than a 40, then her grade will be higher than a 70. All right, so anytime I give you guys a problem like that, this is the general pattern. Take all the grades you have, okay, add them up, put plus x, because you're going to have one more test score, you don't know what it is, and then divide by how many tests she's taken. Okay? Make sure when you divide by that number, include all the ones she's taken, plus the one more test she has to take. Okay? And then set that equal to the average. Okay? All right, any questions on that? All right, so for the last one, just have you guys try that one. Okay, try that on your own, see if you can solve it. Once you finish that, I'll come around, check it, and then we'll put up your homework, and then that'll be it for today. So Victor mentioned, looked at our denominators, 2 and 5. He found the smallest number that is in both those lists, which was 10. So we're just going to multiply everything by 10 over 1. Sometimes it's a little hard to squeeze it in, but just try to squeeze it in right here. And if you're kind of uncomfortable, you're looking at this 4 and you're like, whoa, wait a minute, that 4 is not a fraction, everything else is. You could always put it over what? Put it over 1. You could do the same thing with the 7. Now everything's fractions. All right, so now try to keep going through it and see what you get. Okay, one thing as I walked around a little bit that I noticed, some people forgot to multiply everything by 10. All right, kind of think of it as like you got to be fair, right? If you're going to multiply this by 10, you're going to multiply the 4 by 10, the 1/5 by 10, and the 7 by 10. You got to do it everywhere. What happens is if you forget to do it in one spot, it comes out wrong. All right? So make sure if you're going to multiply something by 10, you do it to everything. All right, and if we start to reduce, 2 goes into 10 how many times? 5 times. 2 goes into 2 once. Look at here. Denominators are already ones. There's nothing to reduce here. We're just going to do 10 times 4. We'll do that in a second. 5 into 10, how many times? Nice. Victor, 5 into 5? 5 into 5, how many times? Once. Okay, look at this one. Denominators are already ones. Is there any reducing? Nope. So we'll just do 10 times 7 in a second. All right, we've got 5 times 1 with a y. It's 5y minus, what's 10 times 4? 40. Equals, what's 2 times 1y? 2y. And what's 10 times 7? 70. Okay. Now we just need to get y by itself. Okay, we're at our adding and subtracting step. Anybody tell me what I could add or subtract from both sides? Let's try to avoid negatives if we can. Yeah, go ahead, Alexis. Well, we already have a minus 40, so we can't subtract it again. It won't cancel it. But we could do the opposite of minus 40. Yeah, we could add 40. That's good. And now negative 40 plus 40 gives me 0. Got 5y on the left. And 70 plus 40, it's a little big, but 110. What do we do next? I think we still have a little bit more adding and subtracting. And say, yeah.
Subtract 2y.
Good, we're going to subtract the 2y. Subtract the 2y. And what's 5y take away 2y? 3y. All right, since you guys have done an awesome job today, I'll finish it up for you. Last step, you got a number next to a letter. You always use division. All right, so in this case, we're going to get a decimal. Just use my calculator. 36.7. So if you get a decimal, don't think you did something wrong. That might just be how the problem works out. Okay? All right, so
It might be easy to use the,
So I had another average one, guys, but don't worry about that. For tonight, okay, we're going to give you a worksheet. I don't think there's an average one on there,
no,
but
it's a word problem.
the average one is going to be on the test. Okay, you will have an average one on the test. So keep that example handy for the test. All right, don't forget, we'll review tomorrow, so nothing new tomorrow.